All right, thank you for joining us. This is the CTE Industry Connection Series. Today we are featuring the Structural Engineers Association of New York. I welcome all of our young people. What I'm going to be doing throughout this presentation is dropping the attendance form, so make sure you guys fill that out. And also, as I've been trying to tell your principals, your teachers, please, I encourage you, ask questions, make comments. These industry partners are here for you guys. They're not getting paid to do this. They're doing it because they want to meet you. They want to hear about your questions and concerns. And we want to encourage you as you pursue your careers. So please feel free to use the chat box, drop your questions and comments right there. Before this session is over, again, it's very, very critical that you fill out the attendance form. So take a look out for that. I'm going to be dropping that in the chat box in a couple of minutes. And I'm going to turn it over to the engineers. Thank you, folks.
Thank you, Gav. Really appreciate this opportunity. Hello, everybody, and welcome. My name is Jason Fiore, and I'm here today with my colleagues Anne-Marie, Katherine, Mig, Luis, and Matt from the Structural Engineers Association of New York. We're all really, really excited to be here to talk to you today about engineering. Here is the list of some of the topics that we'll be discussing. We will start off with the basics of engineering, then move into the different disciplines and what each of those entail, followed by the specifics of what we as engineers do on a daily basis. And then we'll conclude with question and answers from the students so that each of you can walk away today with a much better understanding of what the future could hold for you as an engineer as you progress through your CTE program and on into college. There is a chat feature, so please feel free throughout the presentation to put your questions in there, and then we will be gathering all of those, and at the end of the presentation, we will field those questions. So I'm going to pass it off to Anne-Marie, who's going to get us started off.
Hi, everybody. My name's Marie Bugler. I'm a structural engineer, and this is the start of what is engineering. So engineering, according to this one definition, just to give an example, is understanding how the world works and applying the knowledge of math and science to solve problems through the process of designing and building things. So one way that that's done to help people get on the right path that might want to be future engineers is to be going into schools that have STEM programs. So in case any of you guys aren't sure what a STEM program is, it's basically an approach to learning that integrates the areas of science, technology, engineering, and mathematics. So through STEM, students can develop skills in problem solving, creativity, all that kind of stuff. So I think basically you guys call it, what is it, the CTE program, right, Reed? Yeah,
Yep.
So I think that's the same thing out on Long Island where I grew up. Some of the schools out there call it STEM programs, but it's the same thing. I mean, you guys are definitely on the right path being in schools like this if you have a love of math and science, because you're definitely going to have an advantage eventually if you want to become an engineer in school, having this extra background and having these extra classes that some kids in regular schools wouldn't have the opportunity. So if you want to go to the next slide, Jason. So there's different, so I'm just curious, for the kids that are watching, are our four faces like on the slide, like blocking the slide a little bit? People watching, or is it just one person? Because I see four.
Just one person.
There's one.
Fine for me.
Oh, just one?
Yeah,
Okay.
Yeah,
fine.
person.
Because it was blocking part of the STEM part of the slide before, so I just want to make sure everybody can see everything.
So,
Okay.
and Marie, it depends on the format of the person who's viewing the screen. So right now, I actually see several thumbnails, but at the upper right-hand corner, the person who's watching can choose if they want to see just one person or a gallery of people.
Oh, okay, cool. I'm not that great with Zoom, so I wasn't sure. Okay. So if you guys think that maybe you one day want to become an engineer, there's all kinds of engineering. Oh, not yet, Jason. So just some of the ones here. If any of you guys have your phones with you, if you want to take a picture of the screen, you might want to Google these later just to get a little more detail into the different types of engineering that are out there. So there's aerospace, there's agricultural, there's audio, there's biochemical, there's bioengineering, biological, biomedical, ceramics and materials, civil, which is the one that we're going to focus on today, computer engineering, computer science, electrical engineering, environmental engineering, geotechnical and geophysical, industrial manufacturing, marine and ocean, mechanical, nuclear, petroleum, plumbing. So there's definitely a lot. But the nice thing you'll see about civil today is within civil, there's also a lot. So you can get a broad degree in civil engineering, but then you'll see the different facets it's broken down to. And we'll get more into that in the next slide. So civil engineering, the first facet of it is structural engineering. So if you see people that are designing buildings or bridges, that's a facet of civil engineering. So that's a structural engineer. Another facet under civil engineering that you learn about when you're in college would be geotechnical. So you have the building going up or the bridge going up, but what's supporting it so it doesn't like sink into the ground. So some people in civil engineering, when they come out of school, go to work for geotechnical companies or foundation companies, and they're the ones that design the huge concrete slab that you're going to build your building on top of, or your bridge will sit on top of. Then the next facet that you'll learn about if you went to school for civil engineering is transportation. So you'll take classes on designing roadways and highways and how they figure out where you need traffic lights, where you need expressways, all that different kind of stuff. So you could graduate with a degree in civil engineering and say, hey, I want to go work for like the New York State DOT or the New York City DOT, or I like the idea of designing like roadway systems. Another facet that you'll learn about with the civil engineering degree in college is environmental. So if you think you want to go into more environmental stuff like water resources, like figuring out like wastewater treatment plants, water treatment plants, stuff with the environment, just a heads up, some schools have what they call environmental science, and sometimes that's a BA, a Bachelor of Arts, and then some schools have environmental engineering, and that's a BS, a Bachelor of Science. So most of the jobs that you get if you want to be an engineer want the Bachelor of Science more over the Bachelor of Arts because it's not as mathematical focused. So again, if anyone on this call ever wants to go for environmental engineering, be aware when you apply to schools, because I've had some friends in the past apply to a school for environmental science and they didn't realize there's a difference. But just know there's a difference, environmental engineering versus environmental science. But again, if you go for a school that has civil engineering, in your 4 years there, you're going to take general courses, and then in your last couple of years, they'll have you focus in on structural, geotechnical, transportation, environmental. And then your last year, you could take extra classes in any one of those four. And then when you graduate, then you might want to go more, okay, I want to be a building engineer, work in buildings. I want to be more of a transportation engineer. I want to work on the foundations part. So it's all up to you. There's a lot of freedom. And in general, even that other list with all those different engineering careers that were on there, mechanical, electrical, your first year or two of school, everybody's kind of taking the same things. You're taking math, science, English, gen eds. It's after your first couple of years that then you focus in on more, do you want to be a civil engineer, mechanical engineer, this and that. So your first year is more general, but don't feel like, you know, at 18 years old, you got to know right away, but just have an idea of what you like. So at least you pick a school. Like I went to University of Buffalo, they had mechanical engineering, they had aerospace engineering, they had civil engineering. So at least when you got in there, so when you start taking classes, you might say, all right, I want to go to this. Whereas if you go to a school that only has civil engineering and that's it, then a year later you might say, oh, I kind of like mechanics. Maybe I want to be a mechanical engineer. And then are you going to have to transfer schools? So again, you should think about all the things you might want to be and make sure or try to pick a school that has those different options just in case you do change your mind. Okay, next slide.
Who answers the questions?
I'm sorry?
Who answering questions?
Yeah, I think you guys can enter in questions and then we're going to wait to the end to answer them just to make sure we get the presentation so we don't run out of time. But feel free to put them in the chat or you can just ask them at the end part when we're going to have a question and answer session. So then structural engineering in general, typically you do design of new buildings or renovating existing buildings, bridges, foundations, roadways, dams, piers. There's pretty much anything that's built out there, a civil or structural engineer is involved with. And then part of it is balancing the requirements to be efficient, especially nowadays with, you know, green, and you guys, I don't know if in school you've heard about things called like LEED, but it's like different standings for making things more environmentally sound. So you help with the carbon footprint, that kind of stuff you get involved with. And And then as an engineer, sometimes people think engineers are like introverts, like they just sit down and number crunch and do calcs all day and they don't talk to anybody, like nerd alert. Like, I mean, some are like that, but not everybody. So you can be more of this number cruncher all day if you want, or you could get involved with working with as a liaison, like some engineers in a firm will go to meetings and work with the architects and the mechanical engineers and the construction managers. Some engineers will go to firms that let you do design, and then you'll actually go out in the field and inspect it. Like you'll watch it being built. Like one of my first jobs, I started off, my focus in college is more structural engineering, but then my first job was with a company doing bridge engineering. And my first summer I did inspection on the Williamsburg Bridge, like an assistant to a main inspector, basically climbed around the bridge for the summer. It was pretty exciting because they said, before you design anything, you got to see how it works. And then the next summer, I was in the office doing design on like the Brooklyn Bridge. This is in the late 90s when they replaced the roadway decks. So I helped do that design. And then a year later when it was being built, I was out in the field watching them do the welds, watching them put all the decks in. So that's another cool thing about engineering. And different companies, some companies will do that, like you'll design it and then you'll be involved with watching it being built, inspecting it. And then some companies just do design and then they hire a different company to do the inspection part. So there's lots of facets, and if you feel like you're not like sit behind a desk person all day long, just know, because some people think, oh, an engineer, I'm just going to sit behind a desk and do calcs all day. No, there's so many different things you could do in engineering, which is what makes it so exciting, and it's kind of endless, and it's up to you. So to talk a little bit about a firm that lets you do design and then go out and see it built, my friend Katherine is going to start with the next slide and go over a couple projects she's worked on with her company. So Katherine, take it away.
Thanks. So my name is Katherine Rivera, and I have been in the field for about 2.5, almost 3 years, and I've already gotten to work on some really cool projects. And I work at a smaller company, and so like Anne-Marie was saying, like we work very closely with the architects and the owners and the other mechanical engineers to make a building come together. And so, for example, this is a new construction building for NYU, and NYU, it's in New York, and they only have so much space to build. So they're trying to put everything that the school would ever need in one building. So there are 4 basketball courts in the basement with a building on top of it and 2 buildings on top of that. So that's a really interesting problem with a lot of coordination and a lot of very particular architectural challenges that we as engineers have to problem solve to make this building work. And so that has been a really interesting project. And I got to be introduced to that really when I was new in the field, and that's been an incredible learning experience. And it's been super satisfying to see it come together. They topped out, I think about last month, that all the steel is up, and NYU is actually going to get to use this next year, which is also very satisfying to know that something I built, I can walk down the street and see students using. Next slide. And then the next project I worked on is this renovation on a renovation. The original Penn Station was built in like 1908, and they tore it down in the 60s and put up this not particularly beautiful office building, which you can see in the middle there. And instead of tearing down the building and putting up a different building, which wouldn't be very environmentally friendly and would require even more time and expense, they decided to renovate the building to kind of bring it into the 21st century, extend its lifespan, add a lot more usable and functional and fun space. They're putting like a green party roof. So there's like a big terrace where they can have concerts up on the roof now. And that's been a really interesting project of getting to go into the field and actually go and see this original steel from 1908 and see this original steel from the 60s and figure out how to really push this building to its limits to make it a very new, functional, beautiful space. I also got to design a pedestrian bridge to connect 2 buildings, which the DOT is still looking at to make sure we can do it. But that's a really interesting problem that I got to get my hands on and has been a really satisfying project. Next. And then, like I said, getting out in the field, I'm getting to do inspections, to watch concrete pours as they're doing construction, and I'm getting to do forensic assessments, looking at the existing steel and see what needs repaired or see what actually got built versus what the drawings said might be getting built. And that is really nice to be able to get out of the office at least once a week or so, to go see something in person, to go study the conditions, to talk to contractors, to talk to construction workers, and just get a bigger exposure to the projects that I'm working on.
All right. Hello, everyone. My name is Megara. I go by Meg for short. I'm a structural engineer, and I'm going to talk to you a little bit about the requirements to become a civil or structural engineer, or really any type of engineer for the most part. For one, you have to go to a program like Anne-Marie was talking about. You have to apply to mostly four-year undergraduate programs where you would apply to get into a Bachelor of Science engineering program. And typically those are four-year programs. Sometimes there might be like an accelerated program where you can do 4 years and then get a master's with an extra year. Those are all different types of things to consider. At the end of your bachelor's degree, near the end of your 4 years in undergraduate, your professors will start talking about this thing called the Fundamentals of Engineering exam. And the Fundamentals of Engineering exam is a 6-hour exam that's going to test you on pretty much everything that you've learned in your undergraduate studies. So from your, kind of like freshman, sophomore level prerequisite classes, which we'll get into later on in the presentation, all the way through your engineering level courses in your junior and senior year. And after passing that Fundamentals of Engineering exam, you will be able to put some fancy letters at the end of your name, which are EIT, which stand for Engineer in Training, which signifies to potential employers and anyone looking at your resume that you are someone who is now on their way to be trying to become a professionally licensed engineer. Like I mentioned, master's degree is sometimes very heavily recommended. For structural engineering specifically, very heavily recommended that you definitely consider getting into a graduate engineering program for it. You don't always have to make that decision right away. Sometimes you can work for a company and the company will pay for your engineering degree, which is the situation that I'm in currently, that I was in. And sometimes you might do really well in school and you do some research and you can get a research assistantship and get it paid for that way. If you can afford to pay for your own, by all means, go ahead and do that. And the reason why, one, you want to get a master's degree because it's going to really give you a much better understanding of the technical information that was kind of the foundation of it was kind of laid down in the bachelor's degree program. Not every engineering discipline needs to go for a master's degree. Within the civil engineering kind of umbrella, there's structural engineering, maybe geotechnical engineering. You might want to go get a master's. Environmental engineering is another example, one that might need to get a master's degree. I don't know many mechanical engineers that are working right now that had to get their master's degree off the bat. But if you want to work for, say, like maybe Boeing or SpaceX or something like that, you might need to go get that master's degree. And then professional licensure. What does professional licensure mean? Professional licensure basically means that you basically, well, one, you have to pass an exam, another exam, an 8-hour exam, which is going to test you on some stuff that you learned in school, as well as a lot of the stuff that you learn on the job. And it's kind of geared toward what your discipline is, right? So if you're a mechanical engineer sitting for that licensure exam, your exam is going to be very different than mine as a civil engineer. And the same thing can be said for like electrical engineering and so on and so forth. And the idea of these, what licensure means is basically it's a protection for the public that whoever is designing these, whatever it be, a structure or anything that's basically used in the real world that the public might have to use, and there's a safety concern. The engineering licensure, that seal that you see on the right side of your screen, means that I'm guaranteeing that this design is up to code, it's safe for the public to use, and essentially you're putting, you as the signing and sealing engineer are putting your reputation on the line when you put that down. And it's really just a thing for the public to know that this thing is safe. So like I mentioned, there's an 8-hour exam associated with that. If you're going to be a structural engineer, very popular right now, especially out west, is the structural engineering licensure. That's a 16-hour exam, which is pretty difficult to do, but it's something to aspire to for sure. Typically, if you're going to have an SE, you're probably gearing to try and be like a discipline lead, somebody who's who's going to be kind of like a top person within your office. I'll give an example. Stantec's New York City office, 80 structural engineers, one of the highest earning offices for the company. There was 2 SEs of the 80 structural engineers there, and you better bet that they were the go-to person for any like really difficult structural engineering type of problems that would ever come up. And then you might think, wow, okay, so I got a master's degree, I got a bachelor's degree, I sat through maybe 3 exams, I'm done learning, right? That's not true. There's this thing called continuing education, which is basically something that is to say that, hey, you're staying on the up and up of whatever the most latest and greatest information is coming out of the industry in terms of, design practices, analysis practices, things like that. And typically you get these I think it's like professional development hours credits from like conferences that you might go on, like different professional societies will put on technical lectures, things like that. And typically you need to get like 36 hours within a 3-year period. That might seem like a lot. It's not really that much. The companies you're working for will oftentimes have like continuing education seminars every single month, multiple times a month sometimes. A big popular way of doing them is going to a conference and like a week-long conference in your your profession, whether it's mechanical, electrical, structural, whatever, and they'll have like 60 PDH hours available for you to get at that one conference. Like they'll advertise that right on the flyer. So it's definitely a continuing learning kind of career path, but it's also a very rewarding career path. And to me personally, I feel like a lot of engineers would say the same. If you're not learning, it gets boring, right? Like if you're not challenging yourself, if you're not constantly learning, trying new things, it gets kind of tedious and boring. So it's definitely something that I look forward to even. Next slide. Jason. Okay, thank you. All right, so what do you need to kind of keep in mind right now as high school students as you're gearing up to maybe pursue an engineering career path, right? And first and foremost, you want to take as many math and science-based courses in your high school careers. And I would also say, obviously that's the pre-calculus statistics, geometry, calculus, chemistry, physics, earth science. Also, English is on there, right? And you might be thinking, whoa, I want to be an engineer. I want to only crunch numbers. Well, there's going to be, if you want to go far in your career, you definitely want to have not just really good written ability to do technical reports and write lengthy emails sometimes, or maybe you might even be called on as an expert witness in a case for for design, or like a lawsuit or something like that. You definitely want to still be very good at your English. And I would also say, if your high school has any public speaking programs or like a debate team or anything like that, anything you can do to get those public speaking skills up and hit the ground running in undergrad, definitely going to give you a leg up on a lot of people. It's definitely recommended for that. I would also recommend, if your high school offers any AP courses, so like AP Calc, AP Physics, things like that, I would definitely recommend taking them, because for a couple of different reasons. One, if you pass the exam and you apply to a undergraduate program that allows you to use the past AP exam credit towards a credit at the school, not all of them do, you have to look that up. But if they allow you to do that, it allows you to kind of skip ahead. And you'll see that in the next slide when Lewis talks about the different courses you're going to take. The other option is you take the exam, well, actually go back. If you take the AP exam, and then you don't even need to, in the case like they don't even want to take the credit, they don't want to let you skip ahead, they'll still count it as a credit for your overall like credit allocation. And the way that these undergraduate programs like allow you to schedule your classes is based on how many credits you have associated with you at the school. So like, I'll give an example. One of my friends freshman year had like 30 AP credits coming in, but he didn't use any of them to skip ahead. He just used it to be able to schedule as if he was a sophomore and get the perfect schedule that he wanted, right? So that's a way that you could do it as well. And then the other reason, even if you don't want to take the AP exam, I still recommend taking the AP classes because it'll be like you're learning it a second time when you're in undergrad. And these courses, the calculus, the physics, the chemistry, these courses, depending on which discipline of engineering you go into, are like really lay the foundation for you to really understand the stuff at a higher level when you get into those higher level theory courses. Okay, next slide. And Lewis is going to take over and talk to you about a couple of these engineering courses you'll take in undergrad.
All right, thank you, Megara. So like Megara said, my name is Luis Lopez. I am a civil engineer and I work for RAND, which is a small company as well. So some of the classes that you will be taking during college, as Megara mentioned, most common is mathematics, which includes calculus 1, 2, and 3. Like Megara mentioned, if you take the AP exams, you might be able to skip depending on your college requirements. Differential equations is also something that you might take, as well as partial differential equations, which is an optional class, which can help you, which can count for both as a math class as well as a technical class for your civil engineering degree. As per the science classes, you will be taking chemistry 1 and chemistry 2, and physics 1 and 2. This is also the same as the AP exams. If you take the AP exam, you might be able to skip chemistry 1 and physics 1. Also, you might also have to take earth science or material science, in which you learn about the soil integrity and the soil strength of the material, as well as the common strength of steel and concrete, and a combination of both. So that's when you'll be taking material science. As per your technical classes, you will be taking statics or solid mechanics. In this class, you will be analyzing and determining the strength of a member, and the structural analysis, and then you will be comparing it and see if your design, if your material can actually work, and you can actually build it as well. When it comes down to steel and reinforced concrete design, as I previously mentioned, it's all about design. And when it comes down to geomechanics and geotechnical, you will be dealing with the designing of the soil. So as Anne-Marie mentioned, soil is where everything pretty much, we release the pressure of the buildings, bridges, roads. So it's a very, very, very important component in our design. Finally, you will be taking capstone, which is also called the senior design project. In my senior design project, I had to redesign and see what changes can I make to the Tower C, which is located in Hudson Yards. So we had different components. For example, what if you make it out of concrete? What if you make it out of steel? What type of connections? Do you have a moment connection, a brace connection? So those type of connections we take into account in how it will affect not only the budget, but as well as the constructability of the bridge, of the building. Other classes you will be taking electives. They vary depending on which path you end up taking on your senior year, whether you go construction management, you will go environmental, you go structural. So all that depends on that. And finally, you will be taking general classes. So this will be primarily done during your freshman year, which you will be taking like English, psychology, classes like that. But yes, so next. Jason? So yes, so some of the competitions or some of the clubs that you can actually join while you're in college, there are the Steel Bridge competition, which is hosted by AISC, which is the American Institute of Steel Construction, as well as the Concrete Canoe competition, in which is hosted by ASCE, and then the Seismic Design competition, which is done by EERI. I know Megara wants to talk about, because he was involved in one of those competitions. Myself, I was involved in the Steel Bridge competition when I was in college. Go ahead.
Yeah, so I was involved with Concrete Canoe pretty heavily when I was at Penn State. And Concrete Canoe is really cool. I thought it was a really interesting project. When I was a freshman, I was like, wait, concrete floats? I thought it was heavy. That doesn't make any sense. But buoyancy is a pretty strong force. And Concrete Canoe really simulated what a sort of like a full project and like the coordination effort and project management effort kind of feels like in a real work environment. Oftentimes you'll have, there's a lot of different facets to the competition. There's the design component, which includes both design of the material, so design of the concrete, all the different admixtures you can use, pigments, things like that. Then there's the design of the actual canoe. So structurally, how do you design the hull of the canoe such that it won't, there won't be punctures when people get into it. And then there's also the design of the canoe itself. How hydrodynamic is it going to be? Is it going to be fast through the water? And the reason you need to be fast is because there's a racing component, as you can see from the slide, for the picture on the slide there. They actually have they have like a regional competition where you race these canoes against other schools in your region, and then if you place first in the region, then you get to go to the big fancy national competition. There's like a very artistic component to it too. If you're somebody who's artistically minded, and you find yourself in an engineering program, you can definitely get involved. You have to have like a theme to your canoe, and that theme has to carry through like the report, the presentation, the display of the canoe at the competition. The judges judge on all of that. Judges are typically industry professionals, so you get to network with some industry professionals at these competitions as well. You get to network with students and at neighboring schools and see what kind of cool stuff they're doing. There's the presentation part of it. So like I mentioned, public speaking, really important. There's like a presentation part of it, and all those different categories get judged, and then eventually, that's what decides the deciding factor. And it was such an amazing way for me to really get to know a lot of my fellow students at my school. Like I said, I don't know if I mentioned before, but really, when you get into undergrad, look up all the different professional societies that have student chapters at your school, because it's such a great way for you to meet new people who are like-minded. You'll have opportunities for you to travel across the country on conferences and network with people all over the world sometimes, right? Sometimes these conferences are global conferences. So it's such a great way for you to network and make friends. You might think, oh, like I thought this when I got there. I was like, oh, I'm a freshman. I'm not even declared yet. At Penn State, you don't even get into your major until like the second half of sophomore year. And I thought, they're not going to want some freshman or sophomore to get involved with ASCE. And then eventually I became an officer and eventually hull design captain for my concrete canoe team. And I realized I want as many freshmen on the team as possible. And because we want to have continuity after, people graduate. I want to make sure that I have young officers to take over after I, an older junior, senior officer, want to leave. So it's a great way for you to get your feet wet and get a better understanding of the different kinds of theory and principles that you might see in your classroom, and then apply it physically in the real world in these kinds of different competitions. Next slide. Yeah, so like I mentioned, ASCE, American Society of Civil Engineers, I was heavily involved with that at Penn State, and I even continued my involvement. It doesn't end, it's only beginning when you get there at school, at undergrad, right? There's like a whole national society. There's an international version of the society that's applicable to a lot of these, societies listed here. And for me personally, I got into engineering because I was really good at math and physics. And then I got to school, and it was still kind of that way, but I didn't really get a passion for the industry as a whole and kind of what we do, in terms of pushing infrastructure and pushing, the vision of infrastructure forward in society, until I got involved with these professional societies. So that's really where my passion for this industry kind of like blossomed. So I highly recommend get involved as soon as possible. They usually, when it's in person, offer like food, free food at these events and stuff like that. So a good way for you to get some dinner, some pizza and soda, typically is how that goes. Some other, SWE is Society of Women Engineers, which is huge. They're like really big into getting as many women into engineering as possible. Any major undergraduate program typically has a SWE student chapter. Obviously, we're mostly listing the civil engineering societies here, but there's ASME, so American Society of Mechanical Engineers. Same thing goes for chemical engineering, and so on and so forth. So get involved early, and it'll open a lot of avenues to you, and it might even give you some new skill sets and ways of, and it'll add to your skill set for sure. And I'll hand it back over to Katherine to talk about women in engineering.
Meg mentioned the Society of Women Engineers, and I feel like there's a stereotype still that engineering is very male dominated. And while there aren't a ton of women, it's definitely changing. Current colleges have about 22% women in engineering, and the industry is changing along with that. You can see on the chart there, civil engineering is about 23% women, which is pretty good, honestly. And I think that it's really important to have more female engineers in the office. A lot of schools really encourage it, and I really encourage it. I think that it's just a really good opportunity to be in a space where you can make sure your voice is heard and have an interesting different viewpoint. And engineering as a whole is really encouraging of diversity practices, and a lot of companies have specific diversity and inclusion programs to ensure that their workplaces are welcoming and recruiting people of all sorts. Good.
Okay, so my name is Matt Sangan, and I'm going to talk to you a little bit about civil engineering earning potential. So one of the things that people always look at when they're applying to college majors is, how much money am I going to make? And it's a very serious question. At the end of the day, you know, we all really enjoy what we do, but you have to pay the bills. So one of the great things about engineering as a whole, and civil engineering specifically, is it actually has a very high earning potential compared to a lot of other fields. So it's something that we're all very passionate about. We really enjoy what we do. And you definitely get paid in those intangibles that you get to see the work that you're doing as you're walking around the city. But at the end of the day, you also do actually take home a fairly decent amount of money. You're not going to necessarily become a millionaire as an engineer, but you're going to have a pretty comfortable salary. And really the more important thing, because it's not all about money, that shouldn't be your focus in any career field. But with engineering, there is a very strong job market, and that's something that's really important. Engineering is a very resilient field. We do a lot of work in infrastructure, which means that there are investments in our industry even when the economy is not so great. You may see in the news stories about failing or crumbling infrastructure, which is a little bit of a scare tactic, but it's true. Our infrastructure, especially in New York, is aging. New York is an older city. We have a lot of bridges that have been around for 100 years or more, and they need to be replaced and repaired. And a lot of our buildings are older and need to be renovated to bring them into the 21st century. So even when things don't always look so good for the economy as a whole, engineering is usually a pretty resilient field and can survive those sorts of economic turbulence in ways that other industries don't. So you know, you may think that you like engineering, but you're kind of concerned about, you know, will you be able to pay the bills? And the answer to that is yes. Can we go to the next slide, please? All right, so to kind of wrap it up, looking forward towards the future. As I said, engineering is a very resilient field, but it's also a growing field. There are lots of investments in our industry. There are lots of buildings going up, even throughout the last 9 months with COVID. You still see a ton of construction in the city and really across the country, whether it's roadways and bridges or building structures. And there is a projection that over the next 10 years or so, this study is a couple of years old now, but over the next 10 years, there's an expected growth of 6% in the engineering industry. So what that translates to is about 20,000 new jobs in our industry. And it's one of the biggest industries in the country anyway. So really there are a ton of opportunities for engineers in the future. There are new and exciting projects starting all the time. And I would strongly encourage any of you who might be interested in engineering or specifically civil engineering to look into it, because really the possibilities are endless. Please. So in summary, engineering is really about problem solving. We've talked to you about all the different facets of engineering, our design problems that we do, the math and science that you focus on in school. But at the end of the day, what we do as engineers, we're problem solvers. If you enjoy math and then you enjoy science and you enjoy figuring out solutions to things that bother you, then engineering might be the right career path for you. Like Katherine was mentioning with Penn Station, you have to figure out how to take new and old and meld them together. We have to figure out how to work within existing constraints of whether it's an existing building or an existing site, or maybe you're building a bridge over a challenging waterway. Really, that's the fundamentals of what we do is about solving problems and making the world a better place for people. There are always new challenges in everything that we do. No two projects are alike. Everything is a little bit different. You know, you learn some basic principles in school, but when you get out into the industry, you'll start to see things that you didn't see in the textbook, and that's because really no two buildings are alike, no two bridges are alike. Everything is always a little bit different, and that's what makes it difficult, but it's also what makes it interesting, and that's why so many engineers really do love what they do. And because so many engineers love what they do, it really is an amazing community to be a part of. None of us work together. We all know each other through the Structural Engineers Association of New York, which is just one of many engineering societies out there. We get together and we do these types of events because we enjoy it. We're not getting paid to be here. This is something that we enjoy doing. We enjoy meeting other engineers in the field, even though we work for companies that sometimes compete with each other. It's really a very supportive community. People are always trying to learn from each other and to teach each other. There are lots of opportunities for networking and design competitions. Even as professionals, there are opportunities for a lot of these fun events, and we work with students to put on competitions for students, and our organization has trivia events for professionals, things like that. So even though it's a challenging profession, we find ways to have fun too. And I've sort of alluded to it a few times, but I do think the most important part of what we do is making a difference in people's everyday lives. That's the really intangible way in which we get paid at the end of the day. The projects we work on, whether it's a residential structure or maybe you designed a hospital or a bridge that connects two communities, these are things that people are using on a daily basis, and it's going to make their lives better. So really what we're doing, we enjoy it. It's challenging, but it's also something that's going to help people and make their lives better. And it's something that we can see in, whether it's in New York or across the country. The projects we work on often do make a difference, and that's really what makes it worth it. So first of all, thank you all for listening. And with that, we're going to move on, and each of the speakers is going to tell a little bit about themselves, and then we'll give you an opportunity to ask us some questions. Great, thanks, Matt. Yeah, so like we've been mentioning, please put any questions that you have in the chat box, and once each presenter speaks, we will field all those questions to make sure that we get all of you guys the answers that you're looking for. So personally, I went to Stevens Institute of Technology in Hoboken, New Jersey. I did a 5-year program, the co-op program, which stands for Cooperative Education, which is a program that emphasizes getting students in internships very early on. So for me personally, I started out at Stevens thinking that I was going to be interested in mechanical engineering, and through my internships, I had 5 different internships throughout the 5 years. Not only did I determine, that mechanical engineering wasn't the path that was for me, it helped me also figure out within the civil umbrella that I really wanted to focus on structures. Because one of my internships, I worked for a geotechnical engineering firm, and just as much as it is important to figure out where you want to go, it's also important to figure out the things that you may not be interested in. Because what's worse than getting a degree over 4 or 5 years, then finally getting an internship and understanding what the work experience is going to be, and then it turns out, well, hey, I got this degree in whatever it may be, and I really don't enjoy what it's like being a XYZ engineer. So those are all the reasons why internships are super important, and that's kind of what led me towards Stevens specifically. Once I graduated in 2015, I've been working for Thornton Tomasetti I have a lot of experience doing both steel and concrete design for some office towers, hospitals. I recently worked on a school. I also have some extensive experience doing steel connection design for some really tall office towers. The picture on the right side is One Vanderbilt. It's an office building going up right next to Grand Central Station. So I worked on that for almost 2 years, which was a really cool experience. So yeah, like we've been saying, within the civil engineering industry, there's a lot of different ways that you can go about it. And I think it's really important early on in college, like we've been mentioning, get involved in different associations, meet as many people as you can, whether that's fellow students, professors, network as much as you can, and really try to get internships as soon as you can to understand, where you're really passionate about and where you really want to head as a professional. I'll pass it off to Katherine.
You guys heard some of my spiel earlier because I was talking about the projects I've gotten to work on. So the short version is I got both my bachelor's and my master's at Columbia. I did particular architecture was a thing that I knew I was interested in pretty early on. There was a little bit of a thought maybe I would do biomed because I thought that was very interesting, but chemistry is not my forte. So I did concentration in structural engineering, architecture, and then with my master's, I knew I wanted to work on renovations because I think that's a very important part of thinking forward towards being environmentally friendly is saving the buildings that we have. So I did forensics in order to learn more about renovation and like older building design. And then my work has been, as I discussed, both renovations and new construction. And I have a particular interest in parametric design, which is essentially software engineering for buildings. So you can kind of quickly reprogram the building to test out a whole bunch of different versions really quickly, which is a fun, like new technology and way that you can have interdisciplinary tasks in engineering. So that's me.
All right, let me unmute myself. Hey, so I'm Anne-Marie, and just quick background on me. So I don't even know if a lot of you kids on the phone knew much about engineering before this presentation, even though you're in more technical type schools. But when I was a kid, my dad was a civil engineer and he worked for the New York State Department of Transportation. So he did roadway designs, and he actually became like a cement chemist, and he designed, like his title was Innovative Projects Engineer. He was the only one in the state, and he designed a new cement chemistry that he worked on with some various like colleges that he would go out to that would let them shut down, for example, the Long Island Expressway at night. And it was a special fast curing mix, but it would last long term and wouldn't have cracking issues like some of the past ones they used. This was back in the 80s. And they would pour it, and then they could do the repairs at night, and it would cure in 3 hours, and they could open up the roadway in the morning. And then at the time, Mario Cuomo was the governor, so he won the Engineer of the Year award because he saved millions of dollars for the state of New York. And we got to meet Mario Cuomo. I got a picture with him with like a baseball bat, the Mario Slugger that my high school made because they heard I was going up there. Now we have a Governor Cuomo as well. That's his son, Andrew. But Mario was his father, who was back, like I said, in the 80s and the 90s, the governor then. And the cool thing was, my dad back then, he worked his way up. Like, he went to school part-time at Manhattan College, and then he went part-time at City College, but he was a furniture mover during the day. So it was really hard to be like working and going to school. So then he ended up just starting with the state back in the 60s as a surveyor and worked his way up to engineer, but he never actually finished his degree, which you used to be able to do that back then. Now you need at least a bachelor's degree for the most part. So, but just to just give you guys that background reference, I know some kids, when they're going to school, they try and work as well. Like, I mean, some kids try and work full-time. That's like a lot. So I would say if you could avoid it, to just try and go to school. And if you have to work part-time, maybe work part-time, but it takes a lot of time and energy. And I know that they were mentioning before, if you have the AP classes, what a lot of people, like even me, I had like an AP class for calculus, but I still took Calc 1, 2, 3, and 4 in college because it just made calculus easier because I kind of already took it before. So some people might use the high school calc and then say, oh, I could save money on a credit. I don't know. Personally, I would just recommend having the advantage that you're going to do even better and get like an A to get better grades when you're in college. So I would just take the classes anyway, even if you took them in high school, just help you do even better. But because my dad was an engineer, the reason I mentioned all that about my dad was that's why I decided to become an engineer, because none of my friends knew what an engineer was. Like when I used to say my dad was a civil engineer, they'd be like, oh, he drives trains. So like nobody had an idea what a civil engineer was, including myself. So if it wasn't for my dad, I probably would have been a high school math teacher because I was always good at math and science. But that's why we're doing this for you guys, because we're kind of being like now introducing this to you because maybe no one ever talked to you about it before and you wouldn't have even known about it, because I would have never known about it if it wasn't for my dad, because like I said, none of my other friends' parents were in engineering. So I went to University of Buffalo, which is a great SUNY school upstate, very reasonable because, you know, it's state tuition and everything else. So you guys in the New York area, if you want a good school that has civil engineering, mechanical engineering, electrical engineering, they have teaching up there. It's kind of one of those schools I was talking about that would be a good one to look into. I know it's gotten a lot more competitive in recent years because of everything being so expensive. Because basically, when I went to school for room, board, tuition, the works, this was in the late 90s, it was like $10,000 a year. Now, my next door neighbor's son goes there for engineering. And for room, tuition, room, board, the works, it's like $20,000 a year. But if you think about it, that's not really that bad compared to a school like NYU might be like $60,000 a year. And that doesn't even include room and board. So just some other options to think about in the SUNY system. I know Farmingdale out on Long Island, I think has an engineering program now. Stony Brook might, I'm not sure, but those are like the main schools. But also, I mean, I know everything's weird with coronavirus now and everything else, but I would say if you have the opportunity to go away to school, go away to school, have the experience. You could always go for a semester or a year. And if you don't like it, if you're more of a homebody, you miss your friends. But when you go, they have freshman dorms or regular dorms. I'd highly recommend you try and get into a freshman dorm, because then you're with like 100 kids that don't know anybody and you're all in the same boat. And then you meet friends and then you start study groups and everything else. And it's just, you know, the 4 or 5 years you go away to school, if you're fortunate enough to do it, you'll never get that back. And it's an experience like I can't even explain, because you don't just learn about school, you learn about people, you learn about different ethnicities, you know, diversity, inclusion, like the works, because you're just thrown into like a big mixing pot of like all kinds of stuff. But there's so many other things to do in school. Like they were talking about the concrete canoe, the steel thing, like it's just so much fun. So highly recommend it. One other thing, I know that Jason said he had a 5-year program at University of Buffalo. They have a 4-year and a 5-year undergraduate program. So I went with the 5 years, which means instead of taking 18 credits a semester, so like your freshman year, instead of taking physics, chemistry, calculus, English, gen ed, which would come out to be about 18 credits, is kind of a lot. They break the first year into like 2 years. So my first year I took chemistry, Calc 1, English, and a gen ed. And then my second year I took, because then the second part of the first year I took Chem 2, Calc 2, and English 2, and another gen ed. And then my sophomore year I took Physics 1, Calc 3, and then some other like classes we had to take. So basically you break up the chemistry and physics over 2 years, and then the next 3 years are like everybody else's. And I didn't put it on the slide, but I was 1 credit away from a theater minor. And that was the nice thing about going over the 5 years, because if you're just doing technical, like 18 credits, like it's really intense and it's kind of a lot. Whereas when I did the 5-year plan, it just, you were taking 12 to 15 engineering, but then you could take like a fun class, or like if you like creative writing, or if you want to go and do some theater stuff, like some other things, because a lot of people with math and science backgrounds have that creative side. Like I played violin like 3rd through 12th. I was thinking about going to school for music at one point, but then my dad kind of talked me out of it because he was worried, like, what if I didn't make it and at least engineering could pay the bills kind of thing. And he's like, you could do music as the glorified hobby. So then I was also lead singer in a band for a couple of years when I first came out. And we got looked at by EMI Records, but then that fell through. And, you know, so I have a big story and I'm also a civil engineer for over 20 years. And I've had a great run. I worked this place called Weilinger Associates, which now is owned by Thornton Tomasetti. It's like a really big firm in the city. I worked there for 5 years doing bridge design, like I had mentioned earlier. And I worked on Manhattan Bridge, Williamsburg Bridge, helped design the new roadway decks that went into the Brooklyn Bridge. Then I went to the same company that Matt on the call is with, STV, for 4 years. And I worked on the East Side Access Project, which, if any of you know about the Long Island Railroad going through Jamaica, Queens, that's being able to take the train out all the way over to Grand Central, so you don't have to go off at Penn and take subways around. So I worked on that for 4 years. I got my professional engineering license in between. And then I was getting bored of doing calcs, and I said, you know what? I think I'm going to go back to school at night at City College and become a high school math teacher, because I always wanted to teach. And then this job came around with this company called Hilti that I work for now. And Hilti, you might see on job sites, like they have the red boxes with the tools, like on construction sites. But they also make the anchors. So like the way that you attach the windows on the buildings into the brick or the concrete, the way you attach the ductwork overhead, the way you attach anything into a building. Like if you put a picture on your wall with a little plastic sleeve anchor so it doesn't rip out of the drywall, we make those out of steel for like everything that gets connected into a building. So I get to go into engineering firms and do lunchtime presentations, kind of like what we're doing here, but in person. And I teach the engineers how to design when they're doing like their windows in their buildings, or, you know, putting rebar into a piece of concrete that they glue in. I teach them all that stuff. So it's cool. So I got to do the teaching without having to go back to school full time for a couple of years to become a teacher that way. And it's still in engineering. So that's the other thing about engineering. If you try it out and you're doing design and you're sitting behind a desk and you love it, great. Or if you're kind of bored with that, then you could go work for a company like I did with Hilti, where some days I'm on a job site helping a contractor come up with a solution where they have to fix something. Sometimes I'm in an engineer's office helping them. Sometimes I'm teaching. Or you could go into another construction management, where you would work on the GC side, the general contractor, the construction manager side, where you're the one who's like running the job coming up, and out in the field with all the different trades building it. And then we didn't really get into architecture today. Maybe in the future we could almost get an architecture to join this presentation as well, because I think a lot of you guys might say, well, maybe I want to be an architect. Just to give you a brief summary of an architect versus an engineer to keep it simple. An architect kind of dreams the idea of like what the building will look like or what the structure will look like and the artistic looks of it and the beauty of it. And then the engineer is the practical one that says, well, I know you want a floating ceiling in the sky, but you kind of need some beams to support that. So we'll do all the calculations and figure out structurally how to make it sound and how to make it work. The architect doesn't really do any calculations. They just kind of dream the idea. So if you're really artistic and can see things that other people can't see, then maybe you might want to go into architecture, but it's definitely more competitive, and sometimes it could be a little bit harder to get a job in it because there's a lot more of them. And also in school, look at your schools, because some schools will say, oh, we have architecture, but then like at University of Buffalo, for example, when I was there, they had an architecture program, but it only accepted 100 students. And there were 500 students that went there as freshmen thinking, I'm gonna be an architect. But then after your sophomore year, when you had to apply into the program, they only took 100. And the other 400 said, what do I do now? And it was like, yeah, I don't know. So half of them just went into completely different majors. Whereas at Buffalo with the engineering schools, if you get in, the schools are large enough that they basically take everyone as long as you don't fail out. So these are other things to look into when you apply to your schools, that you might want to pick a school, again, like even Buffalo has architecture and engineering. So then you could take some classes in both to see what you like.
We got to take questions.
Oh, okay.
Yeah.
So anyway, long story short, also to have what he was talking about, the for the summers, like even your freshman year, try and get an internship as soon as possible so you can see if you really like it. And if you're in the New York area, our Sione group has a shadow and engineer program we do every winter. So even as a freshman, you could spend a day or two in an engineer's office and shadow us to see if like, hey, like this seems really cool. So, okay, that's my story. Sorry if I went a little long.
Thank you, Anne-Marie. Guys, thank you so much. We have a lot of questions in the chat box. I do want us to try to take the questions from the kids who have their hands raised. So I'm going to leave it up to the structural engineers. Take a look at the chat box where it says participants. There's an icon there where you can raise your hand. Please raise your hand and we'll have the engineers call on you.
Yeah, so I saw Sinai, I hope I'm saying that right. Sinai Simon had a question that she put into the chat and she has her hand raised, so we'll address that one first. So it says, so she was wondering what engineering path you want to get into if you want to get into the industry of building and owning buildings. So those are kind of two. I'll start out. It's kind of like two. They work hand in hand, but they don't necessarily. There isn't necessarily one industry that'll do, say, owning versus building. So like civil engineering, structural engineering, definitely is something you want to get into if you want to be involved with the building part of it, the design, and then the construction of it.
Okay.
Typically most companies will do one or the other. There's not many companies that do both. They'll do like, oh, you're going to do the design, and then you're also going to be part of the building of the engine of the structure itself.
Okay.
Typically,
no, sorry, continue. My bad.
yeah, and then there's also so then there's like the designer, the constructor, and then there's the owner. So the owner typically has like an owner's representative. Typically those are people who are engineers too. They're civil engineers, they're structural engineers. And, after, sometimes you can get a job with them right out of school. Typically they like to, like you work in the industry for a couple of years, gain some experience, and then these owners rep companies, they're basically overseeing the project and managing the project from the owner side of things. So they're looking into, they're kind of looking at the design, they're looking at the construction methods, and they're, kind of getting the owner's vision they're like overseeing the owner's vision, and they're like trying to oversee the engineers and the contractors, construction people, to make sure that they stick to what the owner wants to do. So it's not really, you might not be involved with both sides of it, but you can definitely get into one or the other, or like
if you want to focus on like building, I guess which engineering like group would you focus on? Like,
so right. So there's like it depends on which side. Like my structural engineering is kind of
like building like buildings or whatever, or certain, like if you want to build a library or something, what kind of engineering like group would you want to be in? Be like civil, structural?
That would be us in structural.
Exactly.
Structural. Okay.
So you would go to school for civil engineering, but then in civil engineering, like we were saying, after the first couple of years, all the same general classes, you could focus more then on structural engineering if you want to do more of the soil stuff with the geotechnical, but that's all under the civil engineering degree. You just want to find a school that has civil engineering, and then structural is like one of the main focuses under civil engineering.
Okay.
Right. Yeah, exactly. Like our degrees are Bachelor of Science in Civil Engineering, Master of Science in Civil Engineering, but that's what it says on your degree. But when you look at your resume, for example, and you're creating a resume to apply to internships or full-time jobs, you're going to list out all your coursework, and your coursework is going to be all structural engineering based. So, all right. So I think.
Thank you.
Yeah,
we have another question from in the chat.
No,
Sorry,
I'm sorry. Before we move to the chat box, can we ask Destinea to unmute, because she's been raising her hand for a while.
Yeah.
Destinea, you can unmute yourself and ask your question. Did she step away?
My question was that, I'm sorry, I don't know how to pronounce your name, but you said that you worked on how to build canoes, and I was wondering if that applied also to like plastic canoes, because I went canoeing before, and I feel like the structure of a metal canoe is more sturdy than a plastic one. So I was wondering if if what you learned ties in to also making a plastic one, or is that a different section?
Right. So the concrete canoe competition is meant to be like a fun way of you utilizing the stuff that you learn in like a civil engineering undergraduate curriculum. So it's not like, people aren't making concrete canoes to be like practical, right? So a practical canoe is going to be something that's made out of probably like a like a plastic or polycarbonate material or something like that, right? So it's not really necessarily if you want to get into canoe making, that's probably not, you probably don't want to get into civil engineering, but it could be like mechanical engineering, or like some sort of engineering that kind of gets you into using these kinds of different softwares like SolidWorks and things like that. But yeah, I think you would get into sort of like an engineering program, but I'm not too sure which one you would, maybe material science, something like that. I'm not too sure about which one you would want to get into specifically make canoes as a career path. I'm not too sure.
Okay, all right. Thank you for that, Mig. Michelle Shi, can you unmute yourself, ask your question?
My question is around how many people do you work with per project? Is it a lot of collaborating, and like what type of other professions do you work with?
Great question.
That's a really good question. I think it
Katherine,
depends a lot on the,
go ahead.
yeah, it depends a lot on the project, and it depends a lot on your company. So I work for a pretty small company, but we work on projects of a lot of different sizes. So I'm currently working on a 9-story hospital, but there are only 3 of us working on it. But then we work with the architects, and they have a team of 5 people, and we are working with the owner's representative, and that's another 2 people. So you end up talking to a lot of different people, even though in your office on a single day, there's only a few of you working on this particular project. And then bigger projects might have 10 or 15 people working on them because they're more involved. And like Jason mentioned, the one Vanderbilt building, my office also worked on that, and a ton of people were working on that when that was under design.
Yeah, so and similar situation at Stantec, I was working on this big train maintenance facility, and we were sort of like the lead design of the project. So like we had to coordinate with the architect, the mechanical engineer, the electrical engineer, the plumbing engineer, the tracks engineer, who were all not in our office. They were at completely different companies, completely different time zones, different countries. So, you're definitely going to work with a lot of different disciplines, no matter which engineering field you go into. If you're working on like big, large infrastructure projects, in the public space, you're definitely going to be coordinating with a lot of different disciplines throughout your career. And really the size of the team is based on what the size of the project is, oftentimes.
I just wanted to add, it's super important. In our industry, collaboration is super important, because even though, as the structural engineers say, you don't have anything to do with what the mechanical engineer is designing, or don't really know what processes they're using to design their piece of the project, together, everybody is responsible to deliver a building, a working building that, in collaboration with all the practices, serves the public. So it is also your responsibility to understand, your piece of it, and how that then involves the other people, and how everybody needs to work together to make it overall successful.
Yeah, you definitely can't just think like, oh, I'm going to be a structural engineer, I only have to be knowledgeable on structural engineering topics. No, if something comes up, you have to know as the structural engineer, oh, this design change that I'm about to do is going to affect the mechanical engineer, the plumbing engineer, the architect, and this, that, and the other way. And you have to bring that up to them immediately, so that way they understand what changes are coming and how they have to change their design to make sure that everything's coordinated. Like, it's not uncommon for like big projects to have like a massive coordination meeting every Monday, first thing every Monday, where everyone talks about where they are at the design phase, different problems that have come up, clashing items, things like that. So.
Great, keep the questions coming. And by the way, for the structural engineers, I got some texts from schools. They said this is the best virtual seminar that they've experienced all school year. So thank you for this.
That's awesome.
We're gonna take Michael Bolus and then Marcella. Michael, you can unmute.
Hi guys, really, I'm a teacher at Brooklyn Tech, and I love your presentation. But most of you are structural engineers. And one of the courses I teach is surveying. I teach statics and strength of material structure in general for high school. And what about surveying? Is it related to the civil engineering work?
Yeah, absolutely.
We rely on surveyors a ton.
Yeah.
We don't necessarily do it ourselves for the most part, though some people in the office do have surveying licenses, but it's super useful and really important for us knowing where things actually are.
Oh yeah, for sure.
No, part of your freshman year of college, that was it was either freshman year or sophomore year. I had to take a surveying class for a whole semester, and we were using like the old fashioned theodolites and everything else. It wasn't, maybe because it was the 90s, maybe now it is digital in college, but we were using the old ones that you had to take the measurements and mark it all in the book. And so, yeah, so if you're doing surveying in high school, that's going to help you for college because you do that in college. And I noticed somebody else, It even asked a question about, do you need advanced math to be able to go into engineering? For you guys, I don't know if they still call it sequential 1, sequential 2, sequential 3, sequential 4. That's what the math regents was when I was in school. But at least pre-calc, if you could take that, would be the minimum. You don't need calculus. Like if you're not in AP calculus like your last year, at least if you could take pre-calc, even if you didn't, you could still take calc for the first time in college. But having pre-calc at a minimum will help you a lot when you get into college. Because if you just start in calculus for the first time, a lot of times in college, some of the professors aren't the greatest because, to be honest, they're there for research more than teaching. And you're kind of going to be like, what the heck's going on? And then sometimes the books aren't good. So another important thing, there's things called TAs, technical assistants in college. Go see them in office hours if you're having any problems. And don't be ashamed, because I was question girl in school. And I would go to the TAs to get a little bit of the extra help to get me over the hump if I wasn't sure about something. And it really helps a lot. So don't be scared of math if you don't have all this advanced math, everything else. But if you could take pre-calc before you graduate by 12th grade, I highly recommend it.
Thank you. Thank you guys so much. Marcella, can you unmute yourself?
Mary, I think we're getting feedback from your sound. We're good.
Marcella, if you're still around, you can go ahead and unmute. Okay. All right. Let's try David Cook. David, are you with us?
Yeah. My question, I think it's for Catherine, is like, how much renovating can you do to a building that is 50
You'd
to
be
100 years
surprised.
old? Because
I mean, you'd be surprised.
The structure?
Yeah.
It does, but essentially, this I think also gets to another question that someone else had, is how do you design a building to be safe? We have certain assumptions we make about what the load is. So what all materials are sitting there, how many people are allowed to be in the space. And then we also make assumptions on the other side of how strong is this material. So sometimes something, especially back in 50 years ago, before they had more complicated computation skills that we have, like in terms of computers and software that we have now, they might have been a little over conservative. So we might have a little bit more wiggle room, or we might be able to reinforce things. So for instance, we went from just having a normal roof that just was only allowed to have snow to then being able to have parties up there, because we could reinforce the existing structure because the floor below had like a really high ceiling. And so we could put extra steel to reinforce that existing roof. And we're also adding like a belt around the whole building. And we have these absolutely massive columns coming down and landing on what are actually old columns from the original Penn Station down below the plaza. And that used to hold the whole building, but now it's just a street level. So we can put a whole building's worth of load on it again. And so there were some really interesting problems that we had to solve with that based on the existing conditions. And that changed the architectural design based on structural needs. So you can do a surprising amount to like change the use of a building and make it a lot more functional for the next 50 years.
Okay.
All right. Thank you for the question, David. Next, Sarah. Sarah, if you're there, you can unmute.
Hi, this question is specifically for Catherine or Anne Marie. So I'll also put it in the chat because it's kind of like two questions. So what advice do you have for women interested in engineering, like with battling the stereotypes and, you know, facing, you know, acceptance?
That's a great question. I would say the biggest thing is making sure you get heard. I think a lot of women are raised to be polite, and it's good to be polite, but you also want to make sure that you speak up and make sure that your voice gets heard and that you are getting the respect that other people are getting. And I haven't had a problem with that, but you just want to make sure that you're forward and don't take nonsense from people. Anne-Marie, do you have thoughts? I know you've been in the field longer than I have.
Yeah, to be honest, I don't think it's that bad. I mean, not say it was ever bad, but like, for example, I graduated from University of Buffalo in 1996. So I started there in 1991. And at the time there was 100 in my civil engineering class and 12 were girls. So I'm not sure, I think the percentages are more like maybe 20 would be girls now. But back in the 80s, you know, I would go to like a job site with my dad, like, and go in a trailer and I'd see like, you know, Playboy magazine like there and like weird things. Not my dad.
Oh my goodness.
But no, I'm just saying, like, there was like weird things that you would see, or like they'd have like a calendar with like girls on it with like like weird stuff that you would never see today. But that's how much it's changed just in the last 20, 30 years, where it used to be very male dominated. And if like a woman showed up, it was like, oh, look at her. Like, none of that goes on now. Like, if I go to a job site, I feel totally comfortable. There's no, when people talk about sexual harassment, those kind of things, it's not really, Catherine, I don't know about you, I didn't really experience any of that, but I think maybe back in the 80s and 70s that was kind of going on, but things have changed, and I don't really think you'll have an issue as a woman in engineering. And in firms like Catherine's firm, there's probably like 60 engineers in there. How many women work in your firm? About 15?
Yeah, I think 13 or 14 right now.
Yeah, so that's
Someone's
almost
on maternity leave.
Yeah, so that's almost 25%. So don't be intimidated as a woman to think, oh, it's a man's field. It's not. And in school, I feel like especially your generation with you guys, you're even more diverse and inclusive than anybody was, like back in our time, that I don't think you should have a problem with it. Do you agree, Catherine? I think it's fine.
Yeah, I would say I haven't had problems with it, and I feel very respected by my colleagues, and I felt very respected through college. I think the biggest thing is just making sure like you present yourself and aren't afraid to speak up, and I mean, still be humble, but you have thoughts that deserve to be heard.
Yeah, and I wanted to just chime in. I absolutely agree with Anne-Marie and Catherine and Sarah, and for the other students on this Zoom session. I must tell you, from a Department of Education standpoint, we have a lot of industry partners from engineering, and a lot of our kids, guess what? Their supervisors are actually women in these firms. And if you ever visit our commission meetings, you'll see about half of all the professionals we work with within the field, they are women. So I would echo the sentiments of Anne-Marie and Catherine that in this day and age, in your generation, you'll come across quite a few women in the field. And I don't think anybody wants to put themselves in a situation where they want to treat women badly in the workplace. So I think you'll be okay. All right, I wanted to take Pablo, then Monica. Pablo, feel free to unmute. Pablo Green, if you're still around, you can unmute.
Oh,
yeah, go ahead.
Okay. So for people that are interested in working in the field, what profession would you recommend in the engineering?
So like in the field, kind of overseeing construction sort of stuff?
Well, not being stuck in the office for too long.
Oh, okay. Well, guess what? Civil engineering for sure is something that you want to get into, and it's really, there's a field component to almost every discipline of civil engineering. So civil engineering is like the big umbrella thing, right? And then under civil engineering, you have geotechnical, water resources, structural, transportation, environmental, surveying is one of them too.
Management.
Construction management is the other big one. And basically those positions, each of those disciplines has like a full component where somebody is just in the field the entire time. So like if you think of structural engineering, there's bridge inspectors and building inspectors, and they're never in the office unless they're writing reports. And now sometimes I think there's even software where like you can input stuff in the field and it eases that report writing process too. So civil engineering is a perfect major to go for, to get into, to be a field engineer. And you'll I guess as you go through your undergrad, you'll get exposure to all the different facets of civil engineering. And then as a result, you'll be able to kind of discern, oh, I really like structures, but I want to be a structures field engineer. So I'm going to, I'm going to take all my structures courses, but then when I go to apply to positions, I'm going to apply to construction management firms that deal with structural engineering. And, same can be said of, I think there's even construction management programs, like full undergraduate construction management programs now. So you can even skip that, and you might not even have to take some of those really more advanced technical courses. You might just be able to look at construction management related stuff, and then you'll be in the field from day one without any, without being in the office.
One thing I would note though to what Mig is saying, you can just get your degree in civil engineering, and then when you pick a firm, like for example, Severed is where Catherine works. Severed, as an engineer, they do design, and then they go out in the field like she's done on some of her projects to see it built. And then if you want to be more heavy in the field, they can put you out more on inspection. So when you interview with companies, some companies there are firms in New York City that only do design and then they outsource the special inspection. So you could pick a company that does both, so you could try both. One thing I would warn against for some people that go for construction management degrees versus civil engineering degrees, personally, I would recommend try design and see if you like it. If you absolutely can't stand it, then switch over, because if you get a job out of school working for a contractor, but you could do that too. You could go work in the field all the time working for a general contractor that runs the job being built. You're not going to probably be able to get your PE. That's that professional engineering license we talked about, because you need at least 4 years of design experience or 3 years with a master's. So just think to yourself when you're graduating, try and remember this, because I know it's a lot of information and you're not there yet. You might want to try to do the design and have the inspection mix so you can get that license, because that license is going to help you get more money in the future and just be more reputable. I mean, look, I always say the day before I took the PE, I was the same engineer as the day after. And it's just a big, long test. And I almost feel like right out of college, you could pass it, because a lot of the stuff is like, you have to take review class and like remember a lot of stuff from college, because it has environmental, it has transportation, it has geotech, it has structural, it has everything. And if you're just doing structural only at your company, you'll forget all that other stuff. So again, you might want to just get a company that does both. And one other really important thing to say, when you're applying for your jobs in the future, don't base it all on money. If one company offers you $5,000 more than another company, but company A has much more exciting projects to work on than company B, it's not all about the money. You have the rest of your life to make money. Don't pick your first job on money. Pick your first job based on, will they mentor me? That's a very important question to ask. If I'm a new engineer out of school, am I going to have an assigned mentor, or am I just going to be thrown into the fire? And it comes companies, you're kind of thrown into the fire. And some companies, they have a mentor that will help you get started. These are all important things when you go into the real world. I know you're not there yet, but just always remember that. It's not all about money. And are they going to mentor me? And do they have different groups also? Like, do they have a group that works on renovations and new, like Severed, where Katherine works? Because what if you work on new construction, you're like, God, it's cookie cutter. I'd rather do renovations because it's always different. It's more innovative. Go to a company like hers. So these are all the different things you should think about one day when you're in the real world. And one last thing, because I see there was a question that a girl asked me. She said, what advice do you give those who fear civil engineering because of the time and sacrifices that their career requires? The advice I would give to you is, if you're good in math and science, give it a try. And you could always do something like that 5-year plan I was talking about. So you're not taking physics and chemistry and calculus and blah, blah, blah all at the same time. You could spread out the physics to the second year to kind of calm it down a little bit and give it a try. And if you like it, you're going to be into it, but also find people in school to study with. Don't try and do it all on your own. Get study groups. I had 3 or 4 people I'd meet at the library a couple times a week, and we'd work on our homework together. We'd work on our projects together. And it just made life so much easier, because maybe one person was really good at this part and the other person was good at that part. So we all taught each other. And if you could teach someone how to do something, then you're going to do really good yourself when you get to the exam. So that's another important thing I'd recommend. Even in high school, I'm sure you guys have some friends that you might study with sometimes, but especially in college.
Yeah. To also build on what Anne-Marie was saying, if like sacrificing career-wise, it's really, it could be like a corporate culture thing too. Like if you work for a company that's like very like, workaholic type of stuff, then you might find yourself in a situation where you feel the pressure to always be working, like putting in those extra long hours. But there's tons of companies out there that have this idea, they really value the work-life balance. Mental health is something that's much more talked about these days than it was when I even graduated 6 years ago, right? Like it's something that's so stressed nowadays. So finding yourself at a company that really values your mental health and your contributions in that like 40-hour work week is something that, it's not impossible to find. They're out there. There's tons of them out there. So if you think that you're fearing because you have to make a lot of sacrifices because you're working 60-hour work weeks every week, no. Are there those weeks? Yes, there are those weeks when there's a deadline coming and everybody's working late, but that's not every single week. And then another thing just mentioning, like Anne-Marie was saying, give it a shot. If you're really good at math and science, give it a shot, because I can tell you, I probably know 10 people that I graduated undergrad with at Penn State who did engineering degrees, civil engineering degrees. They're not civil engineers right now. They're working for consulting firms. They're working as salespeople. The business side of business industries really value the way that engineers think. The way we approach approach problems and the way that we can innovate and kind of dissect problems and attack them and be very efficient. They really value that stuff. So if you think that, oh, I'm going to go into engineering and get this degree and I'm going to hate it, I'm not going to have anything to do. No, you're going to be very, very employable. Trust me.
So following
I
up.
also just want to,
Oh,
Go.
I was just going to say, kind of leading on to that, if you're good at math and science, I see someone else who dropped a question about this. I was not particularly good at math and science, but I was determined. I liked the challenge of it, and that actually drove me more. So it wasn't that I was naturally gifted at math. I struggled in math all the way through college, but I was really determined to understand the principles and to learn it. So as long as you are driven and then have that mindset about how am I going to problem solve this? What problems, like what is the core of this issue? I think problem solving is the biggest thing in engineering, and having that mindset, not necessarily like I'm a great calculator.
so yeah.
So
Yeah, I
don't
agree
be
with that
afraid
as
of the
well.
math.
Yeah, I agree with that as well.
One more super important thing I just want to say to you guys, that I almost failed out of engineering and left engineering when I took physics. I don't know if you guys are at physics yet, but you have to learn how to think. It's not just memorizing. If you memorize, you will fail out after the first year. And that's what almost happened to me. I took my first physics exam and I got a 30. But a 30 was a C miraculously, because everybody seemed to get a 30. And I went to the TA and I was open book. And I'm like, how did I fail this? So the first question was, a girl twirls a yo-yo and lets it go at a 30-degree angle. Where will it be in 10 seconds? I'm looking in the tech guide. Where's the example of the girl with the yo-yo? Yeah, there was no example of a girl with a yo-yo. But what it was the TA said to me, he goes, all right, so think about it. He goes, how tall is the girl? And she was 4 feet tall. He goes, all right, so you have your y-axis, your x-axis. She lets it go at a 30-degree angle. And we were learning about vectors that I don't know if you've gotten there yet. But basically the formula was velocity equals the initial velocity times acceleration times time. So he's like, how long was it in the air? 10 seconds, you write in the 10. What is the acceleration? It's 9.8. Everything was in there. And then it was like, oh, so projectile. But all I saw was a girl with a yo-yo, and there's no example problem like this, and I got a 0. So he's like, you have to learn how to think. And then he took a book. There's a thing called friction. So it's normal force times a roughness coefficient. So let's call the roughness 1. He put one book on the table. He goes, push it. I pushed it. He goes, so what is the force you're pushing with? If it's a pound book, it was a pound. He put 10 books. He goes, what are you pushing with to move that? I'm like, 10 pounds. Now the formula made sense. Instead of friction equals mu times n, and I was always looking for mu and n, and I didn't even know what the heck I was doing. Or F equals ma, and they gave me M and A in high school physics, and I plugged it in, and I got like a 98 on the Regents of Physics in high school, but I wasn't thinking, I was just memorizing. So learn how to think with common sense. Think about what is actually happening here, and you will make it in engineering. If you just try and memorize formulas, you'll do good in chemistry. You could even do good in math, because everything in math, I have a bit of a photographic memory. So I could remember the problem, how the teacher did it on the board, and I would do it and get 100, but I didn't even understand what I was doing. So learn and want to learn that, and the TAs will help you learn that and ask those questions, because if you understand it and are just okay in math, but you can understand it like Katherine said, then you're going to get it and you're going to do better than even the people that are good at math and science, but they're just memorizing. Don't just memorize. Common sense. Put common sense thinking into these problems and think about what's really happening here and apply the formulas that way, and you'll make it.
Yeah.
Great responses. Thank you guys so much. Monica, I see that you've been waiting for a while. If you're still around, can you unmute?
Sure. So the question I wanted to ask is for all the presenters here. After you graduated from college or university, how long did it take you to get a job and get used to and settle in with whatever occupation that you obtained?
So I can answer that question to you since I'm the one who just recently graduated, not long ago. 2 days. It took me 2 days to get a job right after I graduated, and it took me 2 weeks to start a job just because I wanted to take those 2 weeks off.
Wow.
So you can actually find a job really easily, especially back when I graduated. Nowadays, especially right now with the pandemic, it might be a little bit different, but the opportunity is definitely there.
Yeah. I would say also another thing to consider, I don't think we mentioned this when we're talking about all the different programs you can consider. Also consider which universities or programs you're applying to have really good alumni associations. You can oftentimes look up what their career services looks like. One of the reasons I went to Penn State, even paid out-of-state tuition, going from New Jersey to there, is because their alumni network is massive. They have 100 companies coming just to recruit civil engineers. So, you know, and then the College of Engineering program career fair is even bigger. So, you know, that's a lot of these schools now have these career fairs where companies come, they pay money to the schools to come recruit students. And engineering obviously is something that's always highly recruited, something that's always there. So, you know, you're going to go to these career fairs, you're going to go up to recruiters, you're going to give them your resume, and you're going to talk to them about why you love their company and you're so interested to work with them and things like that. And those things, you know, those connections end up leading to interviews more often than not. And yeah, you know, it's you know, that's kind of the process these days. Plus, you know, obviously there's a lot of online application processes and things like that now, but you know, there's lots of infrastructure in there for you to succeed in finding a job at whatever school.
It's also a great reason. It's also a good reason to get involved with the industry organizations. You get to meet people from a lot of different companies, learn about the kind of company that you'd want to work at, and then get to talk to somebody who works there, and maybe they could pass on your resume.
Yep. Always follow up an interview. Day of. Say thank you.
Like the shadow engineering program that this group Sione has at school in the New York area that there's student chapters, like I think Manhattan College has a student chapter, Cooper Union has a student chapter, Columbia has a student chapter, City College I think has a student chapter. So, you know, and also Reed our guest could always get you connected with us as well if you go to college, even like outside of the area and you're coming home for spring break in March and you want to do our shadow engineer event that we always do in March every year too. You could do that as well to get into a few firms in the New York area to get an idea of where you might want to apply.
Yeah, New York is a great place. There's so much opportunity here. Every major company, every major engineering firm has an office here, you know, so it's a great place to work.
The students from Arts and Design are designing a skyscraper competition, and they're asking if you would like to join their class to talk about skyscraper structures. Would any of you be interested in talking to the class about that?
I mean, Katherine for sure, I would assume.
I think Katherine designed a skyscraper.
Yeah, I don't have any skyscraper design experience, but I mean, of course, I'd, you know, love to talk to them about some stuff. That'd be great.
Yeah, I'd be more than happy to be involved.
Jason too.
Oh yeah, Jason at One Vanderbilt.
Yeah, Jason's work.
Yeah, Jason's
on the tallest one.
Hey guys, Google One Vanderbilt, and then that's Jason. So there's a skyscraper.
It's the
I think it's
the
one of the
fourth tallest building in the city.
Yeah, exactly.
Right?
It's crazy.
Actually, Catherine's company, Severed, designed it, but I'm not sure what part Jason's company had to do with it. I didn't realize they were on it as well.
Thomas said he did the steel.
He did the steel connection design.
Oh, okay. So both of these guys, Katherine and Jason, were involved with one of the tallest buildings right down in Manhattan.
Yeah.
So Toronto City, they also worked on the Hudson Yards project.
Hudson Yards, yeah. Yeah, that One Vanderbilt project is super cool. I saw a presentation on it and I saw the parametric design and stuff like this. That's stuff super cutting edge stuff. Like you're talking about like a architect wanting to change the way the building looks. And then as soon as they change the way the building looks, it outputs to another software, which then changes Katherine's analysis software and then changes Jason's, you know, like analysis software and then changes the mechanical engineering and the plumbing engineer software. So it's all like together. And it's like one, you know, it's like, it's crazy. It allows for a design process that's like so fluid and quick to change. And that's really cool stuff. I haven't been able to work on something like that yet, but it's really, really cool stuff, cutting edge stuff in the civil engineering industry.
And then on that same project, the way that the steel that Jason came up with, the corrugated sheeting that you put over the steel to pour the concrete, Hilti is my company. We designed the actual fasteners to fasten that in for that structure. So this is how we all work together.
And Stantec did the connection to Grand Central.
So there you go.
Yeah. So the underneath part of it, you know, that whole like nice, real big entrance into Grand Central from the bottom of One Vanderbilt. That's civil engineers too, working on that stuff.
7 degrees of Kevin Bacon. We got 5 degrees.
Yeah, 5 degrees of One Vanderbilt.
We are all connected. We didn't even realize it. Holy cow!
Yeah, crazy, right?
All right. Some of the students are asking, how do you improve problem-solving skills as a high school student?
Oof. Damn, that's.
That's where you got to think and not just memorize. You got to think and not just memorize.
It's like a practice thing. I remember, I mean, like honestly, I remember studying for like the standardized tests, like SAT and, you know, that stuff. I feel like it's kind of like it tries to make you, it trips you up sometimes, that kind of problem solving stuff. I feel like the math and the physics classes and things that you take in high school are definitely laying the foundation for like how you're going to approach problems in undergrad. So, you know, doing those problems, the repetition there, you know, doing all the homework your teachers assign, maybe even doing some problems they don't assign, right? Like it's, you know, anything you can do to kind of get more exposure and, you know, really test your thinking skills, like Anne-Marie was saying, you know, definitely recommend that for sure.
Yeah, I think there's actually not that much of a difference between a word problem that you might do in math class and what we end up doing talking to architects. If I need to increase the depth of a beam above a staircase and the architect tells me, well, you can't come below 7 feet because we need headroom, then I essentially am doing a little geometry problem to say, okay, the architect needs 7 feet of head clearance and my stair is here, so I can lower my beam by 4 inches. That's all I've got left. So it's really a word problem from what the architect is telling me. So those kind of skills of developing what are the core problems that somebody else has that I can use as my constraints, it's really the core of what engineering is figuring out where your limits are.
Yeah. What are your givens? What are your constraints? And how do you work within all those things?
Probably one of the most important classes you'll take in high school if you want to be an engineer is physics. But unfortunately, not all the physics teachers are as strong as others. So if you know in your school you have like people rave about that physics teacher, get in that class, because that's the physics teacher that's going to do the little experiments and like show you like a door and how it moves and then what the forces are and how it relates so you could see it and visualize it. So then when you do the equations, you can get it and you're not just memorizing. Because when I was in high school, I actually had a physics teacher that probably should have retired a long time ago. And he was F equals MA and he gave you M&A. And I thought I was great in physics, but I realized later on it was just he wasn't a very engaged teacher and just made everything simple because he kind of was on his way out to retire. But not everyone who's about to retire is like that. Some of the ones that are about to retire, you don't want them to retire because they're actually amazing. So take advantage. If you hear you have a good physics teacher in your school, take that class because that will open up your mind and make it so much easier for when you get to college. They could teach you how to think, like I said, practically and not just memorize.
Yeah, similar to you, Anne-Marie, I had a high school curriculum where I felt like it was very easy to just memorize things and not critically think. So when I got to college, I struggled with it because I was forced to do it for the first time. But one thing that I did do or did get involved in that helped is they allowed students to tutor other students. So for example, juniors and seniors in high school would tutor freshmen on, you know, geometry classes or, you know, early biology classes, for example, that you might take as a freshman. And that opportunity to be a tutor helps you as the tutor, because in order to teach somebody else, even if you understand it, you have to have an even better understanding of it to be able to teach somebody and to get that person to understand. So that forces you to then revisit what you know about it and then take it to another level to teach a person who's struggling.
Definitely.
Yeah, and take those AP classes if you have them, because they really give you a leg up on those like Calc 1, Calc 2 physics with physics-based calculus classes that you take your freshman year. That like I didn't go in and use the credits to skip classes. I used the knowledge I learned through my AP classes. I had a fantastic math teacher in college or in high school. I had a fantastic physics teacher in high school. I was very thankful for that. And they made it so that way those classes were a breeze. I mean, I got A's in both those all those classes my freshman year, which is nice, padding that GPA with those early classes for sure.
All right, thanks everyone. We're actually past our time. We still have a couple more questions. Do you feel comfortable sticking around a little bit? Do you have to go?
I can stick around.
Yeah, we can stay. Yeah.
Okay, so one of our students was asking, so you guys mentioned that there were certain certification and licensure exams that a person has to take. They were wondering what happens if you fail these examinations? What are your next steps if you fail these examinations that you have to take?
All right.
So that's not, oh, sorry.
No, go ahead, Matt.
We haven't heard
So
from you.
We haven't heard from you.
yeah, I know it's been hard to jump in. So
Sorry.
it's actually not uncommon at all that for people to fail those exams. They actually, a lot of them have a very low pass rate. For the PE exam for civil, I think the pass rate is like 65%. So you can take it again. Basically, if you don't pass it the first time, you go back, study some more, figure out what you did wrong, and you take it again. And the nice thing about those exams is that there are a lot of references out there. There are practice classes, there are practice exams. Most companies, I would say, including my own, are very supportive of people getting licensed because it's a huge part of your career. It's necessary for advancement. So many companies will pay for people to take review classes. You can talk to your colleagues who recently took the exam, learn about their experiences. You can buy the practice test so you can know what to expect on the day of. But if at the end of the day, if you don't pass it the first time, that's okay. Chances are a third of the room or more will be in the same boat as you, and you can take it again, and you'll probably pass it the second time around. So. It's a little scary, but it's at the end of the day, it's you do have that opportunity to take it again. It's not like if you fail once, your career is over. It's not uncommon.
Yeah, those are multiple. Well, for now, it's multiple choice. I heard there might be changes in the future, but for now, they're multiple choice questions. So, it's not like open ended. It used to be completely open ended way back in the day, and then now it's multiple choice. And then I heard it's going to be kind of hybrid later on. And then to build on what Matt said, if you failed any of those exams, the FE, the Fundamentals of Engineering exam, which you take while you're typically in school or right after you graduate your undergrad, or the professional engineering licensure, which is like later on, like 4 or 5 years into your career, if you fail, they actually give you a breakdown of where you went wrong. So oh, okay, I did really bad in the water resources questions, or I did really bad in the geotech questions. Hopefully you don't do bad in the ones that you're in. Hopefully if you're a structural engineer, you're doing well on the structural engineering questions, but sometimes those are really hard too. But yeah, no, it's not the end of the world if you fail. Lots of people, it happens all the time. Yeah, it's a lot of persistence. Persistence is key.
The nice thing is they're all pass fail too. So
Yep.
if you fail, the interesting thing is if you fail, they give you a breakdown of what you did wrong. If you pass, you have no idea.
No idea.
Knows what the passing score is because it varies from test to test based on how people did. You could have passed it by one question. You could have gotten 100. You would have no idea. They just send you a little notification that says pass or fail.
But take a review class for sure, because I took a review class, and if I didn't, I don't think I would have passed. And to be honest, I could have taken it almost right out of college. It's like a lot of the stuff you learned in college. And when they just mentioned that FE exam, that's the one that you take at the end of your college. Take it your last semester of the end of college, because that's what I did. I had some friends that were like, "Oh, I'll take it after I graduate." No, because then it's like taking a test 6 months after. Like if you finish school in June and then you took a test next December, you're not going to remember it the same. So take that one while you're still in school, your last year, get it over with, because you'll regret it if you don't. Because my friends who did it, a lot of them didn't pass because they forgot a lot of stuff, and then it was hard for them to pass it.
Right, and a lot of your friends will be taking those exams too, the Fundamentals of Engineering exam. Like everyone in your grade, is going to be taking that. So like you can get study groups together.
Yeah.
Go over stuff you're not too sure about. Sometimes the professional societies, the student orgs will like have legit like professor led, or like somebody's really good at a certain subject, like they'll lead like a a course kind of type of thing about the different different problems that you have to solve. So yeah, definitely review courses for sure for the PE exam. That I wouldn't have passed mine without without that review course.
Yes. So also other exams that you can actually take other than the professional exams. Anne-Marie mentioned that you can actually be a special inspector. You can actually take those exams, but in those exams you actually have a limit of how many you can take it per year. So that is a bit different than the PE or the FE exams.
All right, thanks, folks. So there's a question here. I'm going to try my best to refrain from answering it myself, but some of the kids want to know, what's the difference between working for a government entity versus private? And I'm a government person. I'm going to hold my thoughts, but they want to hear from you. What's the difference working for the government versus a private firm?
So, so oftentimes, right, if you think about the types of projects that we work on as civil engineers, like roadways, bridges, things like that, they're sort of public, they're basically public projects that are handled by government agencies. So like New York Department of Transportation, New York City Transit. And then these agencies sort of are the owner of the project. They're the owner of the project, and then they have the private companies are the ones who end up designing and constructing it. But so you're kind of working on, if you work for the agency, if you work for the government, you're kind of working on the owner side of these public projects. So you're kind of, you might be like a manager, and you're kind of overseeing the design phase. You're kind of reviewing the design documents as they come in. You might be reviewing the construction phase of the project, like on site as an owner's rep sort of thing. But that's kind of my take on the kind of differences between public and private. Private, you're more on like the design and the construction, like actually doing it sort of thing. And on the agency side of things, you're kind of overseeing it from the client side of things.
Other thing to keep in mind when you work for private versus public, when you work for public, you get a pension. So that means when you retire, you get a certain amount of money guaranteed till the day you pass on to the next life. Whereas if you work in private, you have things called like 401ks where like you save money, but then if there's a bad financial thing, sometimes those monies can go all over the place. So some people for stability will go more into the public sector because you might make less money per year. Like we were saying before, an engineer coming out of school might make between 60 and 70,000 a year starting in the New York area. And then they might go up to like 100 within 10 years. Whereas if you work for a state agency or the government, you might only go to like 70, 75, 80. But then when you retire, you might get 50,000 a year, like as a set pension for the rest of your life. So there's a little more stability. But then sometimes you don't get as involved in the design and everything else. Like Meg was saying, it's a little more like overseeing or inspection stuff. So look into both sides, but some people for that stability, like financially, might pick also the public sector versus the private. That's another thing to think about.
Right.
Yeah, in my experience, I work for a private company, but we are a consultant for a lot of government agencies. And my experience, those agencies like New York City Transit, the School Construction Authority, the Port Authority, they have a lot of their own engineers on staff, but they don't typically design very large projects. They typically do some of the smaller work in-house, but when they have a new large project, like I'm working on the design of the new terminal at Newark Airport, that's a very large building, they've hired an outside consultant to do that design work because it goes beyond what they have the staff capacity for. So the engineers at the Port Authority are reviewing our design work. They're representing the owner's interests, like Mig was saying, and they also have people on their side who are involved in the financial and contractual aspects of it because it's a government job. It has to go out to bid. So everything has to be competitive. So that if you're on the government side, you may get a little bit more involved in that process as well. From a legal and financial standpoint, they're kind of managing the funding, managing their various consultants in construction, representing the owner's interests, but the consultants on the private side are doing the actual design calculations. So.
Yeah, and then another plus of working in the government side of things is like typically it's like a lot less stressful, I would say, than working in the private sector. There typically isn't a lot of, you're not really working more than the 40 hours. I think it's even less than that, right? It's like 35 hours a week, typically. Yeah, so typically you're not working those crazy overtime hours and stuff like that, but you're still within the industry and, still working on these cool projects. You're just not necessarily doing the design work, you're not necessarily designing and doing the cool stuff, but you're overseeing it.
So yeah, so I actually worked for both the public and the private sector. During my time in the public sector, I worked as a construction inspector, and then for the New York City and New York State DOT, and then eventually I moved to the private sector for a structural design. And as Miguel and Matthew mentioned, yes, I can agree with that. Within the public sector, you do not have a lot of the involvement within the project. It's typically something that is given to you at a small portion. when compared to a private sector where you get the whole picture of the project.
All right, I have one for you guys. I don't know if this may be a little bit tough. It's a pedagogical question. Rose, if you're still with us, you can unmute if you want to go ahead and ask it. But some of the teachers want to know, do you guys have any idea for engineering projects for kids who may have English as a second language? Does anybody have any ideas of how to approach that? And I know this is a very teacher-heavy question, so it's okay if you guys can't answer it.
So I'm actually, English is my second language for me. So I came to this country when I was 13 and then completed middle school and then eventually graduated from high school and then went into college. So for me, it came down to, I was fascinated by bridges. That was my main goal. It was to design and pretty much, how can I say, it's like it was designed and renovate the bridges that we have, especially big bridges such as, the George Washington, monumental bridges that we have around. So that was something for me, and I got enrolled in one of my town's career fair, which is in White Plains. They actually have an event every year they used to have an event at White Plains High School where they invite most engineers association and colleges, and they talk about their curriculum as well as their competitions and all their programs that they have for high school students.
All right, thank you for that.
I know it's,
yeah, go ahead.
I was just gonna say, I know it's hard right now because a lot of learning is distance, but I think that one thing that's particularly beautiful about structural engineering is that it is very intuitive when you're hands-on. And so if you can work on hands-on projects, even just like toothpicks and gumdrops, you can make a truss bridge. And there are lots of kind of intuitive visual ways that you can share that interest in how a structure works because it is such a hands-on project.
I agree. The basic principles are universal. They don't have any language. The structural engineering is the same no matter where you are in the world. The principles are the same, whether you use metric or English units or no matter what language you speak, the fundamentals are the same. So I would agree with Katherine that something, anything hands-on and visual, I think is a great representation, whether English is your first or second language. It's really a useful tool for anyone to understand how the principles actually apply to reality. I love the popsicle stick and gumdrop thing. We use that for high school students as an example.
Yeah, I was going to say,
holiday party.
If you look at, for teachers, if you're looking at like any of these professional society sites, like ASE and stuff like that, I'm pretty sure they have like some sort of resources for teachers on their website if you dig far enough. Like, sort of like small little like lesson plans or activities that you can do with your teacher, with your students. So, I would definitely, if I was teaching, I would definitely look at some of these professional societies and see what resources are available on their websites.
And I knew when I was in high school, we had like a thing where we had to take straws, like drinking straws, and then we had to build like some kind of truss system, however we wanted. And then we would put weight on top of it to see how much weight it could support. So my dad took me out on the LAE and there was like a cell tower. And then you could see like the cross bracing on the tower as it went up. So we basically took a picture of it and then replicated it. And I came in like second place, just using regular plastic straws, building it the same way that the structural engineer did, because they'd have the cross bracing so it wouldn't collapse. So it's like those kind of cool things. Or we had like a contest where you had to have like a shoe box. I don't remember, like, I think I had a pillow in mine or something, but you could put stuff in it and then we would go up on ladders and drop it with an egg inside. And there was different way people were supporting the egg. So little cool contests like that are cool things you could do. I know those are things that we did when I was in like junior high and high school in different science classes.
Great, I think that covered all of the questions, and we had a much greater turnout than I anticipated. I want to give thanks to all the schools, all the teachers, all the young people that attended. To the structural engineers, I'm inviting you to our commission meeting. If you guys feel free to come by. These are our partnership meetings that we have between industry and our classrooms. I can put you on the agenda for a minute or two if you just want to introduce yourselves to the rest of our schools. who weren't able to make our session today. To our schools who weren't able to make it, as you can see, we're recording this, so feel free to get in touch with me and follow up with me if you would like to have further engagement with either the structural engineers or other industry partners. So on behalf of the Department of Education, I want to thank the Structural Engineering Association of New York for doing this session for our young people. I appreciate the partnership. And I'm going to leave the Zoom session on in case anyone wants to informally network. Again, thank you everyone for your time. Have a good one.
Yeah, Yanua, I see you posted a question that you were
I was
conflicted.
just about to type an answer to that.
Yeah, you're conflicted with engineering or architecture, and you finally decided you wanted to focus on engineering, environmental engineering, and now after the seminar, you're thinking structural also. So the cool part about a lot of civil engineering programs is typically some schools actually separate the two. Environmental engineering and civil engineering are two different things, but a lot of programs, environmental engineering is still underneath the civil engineering umbrella. So when you're a junior or when you're a senior or when you're sophomore or junior and you're entering your major, you can take like those entry, they usually have like a introductory environmental engineering course, they have an introductory structural engineering course, an introductory geotech engineering course, so on and so forth. So you can definitely schedule those two, you can schedule your environmental engineering class, and your structural engineering, intro to structural engineering, like structural analysis class, that first semester of, whenever you're in your major. And I think that intro class will give you a lot more understanding of which pathway you want to go down, because those two are very different career paths. So, but I think you'll get a better feeling for it once you actually take those introductory courses for sure.
Yeah, and I will say, just when you're looking at colleges, do a little bit of research about the programs, because most schools really do have, the civil program usually does encompass environmental and structural. And like at my school, Manhattan College, it was a requirement that you had to take some environmental engineering classes as a sophomore and as a junior. So I came into the program thinking I wanted to be a structural engineer, and I ended up taking a couple of environmental classes because I had to, and I ended up really enjoying them and thought maybe I wanted to do that. Ultimately, I didn't. I ended up sticking with structural. But the nice thing about that decision is they usually both fall within the same major. So you probably don't have to make a decision until you're 2 or 3 years into school and you've actually taken some of the more technical classes in both. And it won't set you back at all, because you probably, if you research the program, you probably have to take both classes anyway, and you'll get a little bit of a feel for them, and then you can make your decision.
I see Ashley Lynch asked a question, would you have your own personal tools? So like working on the site type of thing, like as a construction worker? I'm not too sure. Like for example, as an engineer, I don't really have like a big tool belt per se. I have like a tape measure, I have like a laser measure thing to get measurements off, large distances, like a engineering scale, stuff like that. But I don't really have tools that I utilize.
Companies that you go to work for, though, will give you all of that. Like
Yeah.
they'll give you a computer, they'll give you everything you need, so you don't have to buy that stuff on your own.
Right, exactly. Yeah.
Yeah, the only things that most people do have that they own personally would be references, technical books, things like that, calculators. Yeah.
And steel toe boots.
And steel toe boots. Yeah,
steel toe boots. Or composite toe boots.
Composite toe if you're working your electricity.
Working on transit, yeah.
Yeah, but usually companies supply personal protective equipment like safety vests and hard hats and anything you would need, measuring tools on site. Some people do have their own, but most companies typically provide those.
Yeah, some companies will even give you like a stipend per year to buy PPE for yourself. So definitely look for that and take advantage of that if you find yourself working for a company that does that sort of thing. I see Marcel is asking, do you know of any specific jobs that use SolidWorks? In my personal experience in civil engineering, SolidWorks isn't very common, but I know mechanical engineering companies do use SolidWorks. But I think I had to still take like a SolidWorks class during my engineering seminar or something like that freshman year.
And the skills you learn for SolidWorks apply to a lot of the softwares that we do use, like AutoCAD and Revit.
Right. Yeah, if your schools have like a AutoCAD class or a drafting class that uses like Revit or AutoCAD, or I would doubt you have MicroStation, but MicroStation 2, those are all software that we use to kind of create the drawings that we use as engineers. So if you can get exposure to that either in high school or in undergrad, for sure, most undergraduate programs will definitely give you exposure to those different types of software, most of the time.
But I guess we're good.
Yeah. Any last questions? Okay, thank you. All right, great.
And guys, we put our emails in the chat. So if you have any other questions for any of us, feel free to email us. And hope you guys like this, and hope to do more of these. Gavaskar, thank you for having us today. This was awesome.
Yeah. Time management tips, anyone?
Don't wait till the last minute.
Yeah.
Don't wait. Start, especially in college, if a professor gives you an assignment and it's due in a week, don't wait 5 days or 6 days to start it. If you have some free time, start it that day.
Procrastination will
sound fun, but
I'm the queen of procrastination.
I still have issues with procrastination now. So it's something that, I've struggled with my entire career, but if you put it off, if it's stressing you out and you want to put it off, guess what? It's going to create even more stress when you put it off and you have to do it last minute. So try to create a schedule for yourself. I highly recommend, grabbing some, like getting maybe like a Gmail account or something and using your Google Calendar, just straight up schedule in time for you to do your assignments, study, schedule even some break time too, obviously, but, make sure that you're on top of your schedule and make sure that you're putting it all in somewhere that you can reference quickly and understand what assignments you have to be juggling.
I can attest.
My biggest thing was always when you get the syllabus.
I'm sorry, I was gonna say I can attest to Mick's procrastination because he was supposed to email me something and he still hasn't.
I know, I still haven't sent it to you. I know. I'm getting to it. I'm getting to it. I'm getting to it. Katherine,
I was just gonna say, if you get a syllabus, put all of the assignments in your calendar as soon as you get it, so you can kind of look ahead and see, oh, there's gonna be 1 week that I have 3 papers due. I need to get on top of that now.
Mm-hmm.
And keep a to-do list, because I just forget things. I am super scatterbrained, and if it's not written down in a to-do list, it's gone.
Yeah,
and if you get organized in high school, it'll save you so much heartache in college.
Yep, agreed, 100%.
Definitely.
Yeah, I have to-do lists on to-do lists, and I try to cross out as much as I can, but sometimes it doesn't get there. But yeah, the syllabus is definitely great. Your teachers are telling you exactly when everything is due at the very first day that you get your into the class. So you can pretty much schedule everything out if you really wanted to.
Alrighty, I've got to go. Thank you guys so much. This was so much fun, and I really appreciate all the attention and good questions from the students.
Yeah, some really great questions from all the students. Thank you all, and the teachers too. Yep. Thank you, everyone.
Thanks, guys.
Thanks, everyone.
Thank you.
Take care.
Bye.
Thank you.